Hello everyone. In today's session, we are going to see another two ill effects of using hard water in boiler, which is sludge and scale formation and caustic embrittlement. So, what is sludge? Let us have a look. So, sludge is the slimy and loose deposit of precipitated salts in the boiler tube, depositing at the bends and valves, affecting free flow of water. And what is scale? So scale is hard, tough, thick coating of salts at the inner surface of the boiler which cannot be removed easily. And if water contains salts such as carbonates and bicarbonates, then during steam generation they form scales. So let's understand this better with the help of a diagram. So both sludge and scale are the deposit of precipitated salts. So in boiler, when we are using hard water for generation of steam, the water gets converted into steam, while the dissolved salts which are present in the water, they remain behind. And after their saturation point is reached, they start precipitating out and they form a deposit on the inner lining of the boiler. So this deposit which is formed on the inner lining of the boiler, if it is a loose precipitate, slimy and loose deposit, then it is called as a sludge. While if this deposit of the precipitated salts, if it is hard adhering coating on inner wall of the boiler, then it is called as scale. So sludge is a loose and slimy deposit of precipitated salts on the inner lining of the boiler, while scale is a hard coating on the inner lining of the boiler due to precipitated salts. Let's have a look at what are the causes for sludge. So as said, sludge is caused due to high quantity of dissolved salts which are present in water, and those salts precipitate out after their saturation point is reached to form a loose slimy mass called as sludge. So what are the disadvantages? The first disadvantage is that they waste some portion of heat as they are bad conductors of heat. So sludge is a loose deposit on the inner lining of the boiler. So as a result of which they waste some portion of heat which is given to the boiler to convert the water to steam because they are bad conductors of heat. It disturbs working of boiler and sometimes may choke up the pipes and also reduce the flow rate of water in the boiler. So if the salts get precipitated out in the pipes, then they can choke up the pipes, and if the pipes are choked up, then the flow rate of the water will be affected. How this can be prevented? First, obviously by using soft water or water containing very low quantity of dissolved solids. Second, by frequently carrying out blowdown operations. So during blowdown operations, sludge can be removed by using brush as it is a loose and slimy deposit. So blowdown operation means frequently replacing the water which is being used in the boiler. Now scale. Unlike sludge, there are four main reasons for the formation of scale. So four things which lead to the formation of a hard coating is: first is decomposition of bicarbonates. So if water contains bicarbonates like calcium bicarbonate or magnesium bicarbonate, at the boiler temperature and pressure, calcium bicarbonate gets converted into precipitate of calcium carbonate plus water plus carbon dioxide gases given out. And if it contains magnesium bicarbonate gets converted into magnesium hydroxide precipitate plus carbon dioxide gases given out. So in formation of hard and thick coating on the inner lining of the boiler, two components which are there are calcium carbonate and magnesium hydroxides, which are formed by decomposition of bicarbonates. So this is the first cause for formation of a scale. Second, so the second cause is presence of magnesium salts. If water contains magnesium salt like magnesium chloride, it will undergo hydrolysis in water to form magnesium hydroxide precipitate plus hydrochloric acid. So another cause for formation of scale is presence of magnesium salts because they undergo hydrolysis to form magnesium hydroxide salt, which is a precipitate. Third is presence of silica. If water contains silica, that is SiO2, it will react with the calcium and magnesium salts present in water to form a precipitate of calcium silicate and magnesium silicate. Fourth is decreased solubility of calcium sulfate. So calcium sulfate is soluble in water, but as the temperature increases, its solubility decreases. That means if it was soluble in water and if we are boiling the water, as the temperature of water is going to increase, calcium sulfate is going to precipitate out to form a coating on the inner layer of the boiler. So these are the four main causes for formation of scale in boiler. First we saw was decomposition of bicarbonates, second is presence of magnesium salts, third is presence of silica, and fourth is decreased solubility of calcium sulfate. So disadvantages of scales are again wastage of fuel because it is forming a coating on the inner layer, inner wall of the boiler. So the heat which we are providing, it will not reach the water, it will get wasted in some portion. So it will lead to overheating of the boiler, and if we are overheating the boiler, then there would be an issue of boiler safety. Removal of scales. So scales can be removed by use of suitable chemicals like EDTA, sodium phosphate, calgin, etc. And also it can be removed by blowdown operation. Thin scales can be removed by using scraper or wire brush, and thick scales can be removed by using hammer and chisel. To remove hard and brittle scale, thermal shock techniques can also be used. So thermal shock techniques means we can wash the boiler or we can remove the thick scales by once passing a hot water from the boiler, and immediately then passing a cold water through the boiler. So this is called as thermal shock techniques. So these are the removal methods of scales. How we can prevent scale? So obviously if we use a well softened water, then the formation of scales would be prevented, or we can add sodium phosphate to the water. So it is also called as phosphate conditioning for softening of water, or carrying out frequent blowdown operations to remove sludge and precipitate rich water from the boiler. Also we can add organic chemicals for softening of water like tannin, which forms a coating on the scale forming particles, and this matter can then easily be removed by blowdown operation. Let's have a look at the next ill effect, which is caustic embrittlement. So what is caustic embrittlement? So it is the fast corrosion of boiler caused by highly alkaline conditions of water during steam generation, especially in those boilers which generate high pressure steam. So caustic embrittlement means brittlement of the boiler metal, means the boiler metal becomes weak due to highly caustic, or you can say alkaline conditions. So how this happens? So we can use sodium carbonate for softening of water. So in some cases when sodium carbonate is used for softening of water, some quantity of sodium carbonate can remain behind in an unreacted state. So this sodium carbonate which is there in unreacted state and at high temperature, it gets hydrolyzed to form the hydroxide. So let's see how the reaction takes place. So sodium carbonate at high temperature will get hydrolyzed, means it will react with water to form sodium hydroxide with evolution of carbon dioxide gas. So sodium hydroxide is a strong base. So presence of sodium hydroxide makes the water highly alkaline, and it attacks the bends, valves and edges, that is the stressed parts which are present in the boiler tube. The hydroxide formed comes in contact with the boiler metal through cracks or grain boundaries in the boiler metal and forms sodium ferroid. So it decreases the strength of the boiler metal. So this hydroxide, which is formed by hydrolysis of sodium carbonate, it reacts with the boiler metal, which is Fe, presence of oxygen to form sodium ferroate plus hydrogen gas is given up. So this is sodium ferroate. Now, how this can be prevented? So, if we use sodium phosphate for water softening instead of soda lime, that is sodium carbonate, then this can be prevented. Or we can add some tannin or lignin to boiler water, which blocks the cracks. So, this sodium hydroxide, if it is formed, it will not be able to react with the boiler metal and cause its embrittlement by forming sodium ferroate. Or we can adjust the pH of the water to 8 to 9. So sodium hydroxide is highly alkaline, basic. It is the strong base. So it will increase the pH of water. So we can prevent this also by maintaining the pH between 8 to 9 of boiler water. So you can see the image here of caustic embrittlement. That means the boiler metal is becoming brittle or weak so that it breaks due to presence of highly alkaline conditions. So that's all for today's session, everyone. Thank you.